Hi guys, welcome back to my YouTube channel Open Green Energy. In this video, I will show you how I have made my weather station version 4.0. The new version of weather station is based on LoRa communication and ESP32 microcontroller. The new PCB is designed for ultra low power consumption so that you can run it for a long time without any external power supply. If you are new to my weather station project, then I will suggest you to have a look into my earlier weather station project. The links are given in the video description. So guys, without any further delay, let's move to make the project. I have ordered my PCB from PCBWay, which is the sponsor of this project. You can order high quality PCB prototype for your project from PCBWay. You can also use their other services like 3D printing and PCB assembling. Now I am going to assemble the PCB by using my hot plate. First I stuck the PCB on my table using masking tape and placed the SMD stencil right on the top of the board. Then I have aligned the stencil and secured it by using masking tape. Dispense the desired amount of solder paste and spread it all around the board by using a flat object. You can use a spatula or a credit card to do this job. Now remove the stencil carefully and you can see that the solder paste is uniformly applied on the solder pads of the PCB. Before placing the components on the PCB, I have arranged them as per the BOM. Then I have placed all the components by using a tweezers. After placing all the SMD components on the PCB, turn on the hot plate and set the desired temperature. I have set it as per the soldering paste melting point. Then place the PCB over it and wait until the solder paste completely melts. After melting the soldering paste, remove the PCB immediately from the hot plate. After soldering all the SMD components, we will move to solder the through-hole components like headers, connectors and screw terminals. At last, solder the battery holder. Be sure the polarity is correct. The polarity mark is also shown in the PCB. Now our board is ready for testing. Before testing, connect the antenna to the UFL connector of the LoRa module. Then insert the battery with correct polarity and turn on the switch. I will highly recommend to charge the battery fully before the fast use. The green LED indicates the charging status. The next step is to upload the program to the board. You need an USB to TTL UART programmer to upload the firmware into the board. Download the Arduino code from the GitHub page. I will give full credit to my friend James, who has developed the entire software of this project. The link to the GitHub page is given in the video description. You have to download two codes. One is for the main board, which is the transmitter, and another one is for receiver board. I have made a prototype receiver board by using perforated board. I will make a separate video for the receiver PCB board, so keep in touch. I will make a dedicated video for the MQTT connection and integration with Home Assistant. After uploading the code to the transmitter and receiver board, we may test the board. First, we have to hook up all the sensors to the PCB board, then connect the receiver board to the PC through the USB cable, turn on the switch on the transmitter board and press the enable button. Now open the serial monitor to see the sensor data. I have designed a 3D printed Stevenson screen for placing the PCB and the sensors. You can download the STL files from Thingiverse. The link is given in the video description. I have printed all the parts by using my Creality CR10 mini 3D printer. After printing all the parts, we have to remove the excess support material. After removing the excess support material, the 3D printed parts are ready for assembling. In the assembling process, the first step is to install the PCB holder to the middle cover. First, place the top ring on a flat surface upside down. Then stack the 4 middle rings just above it. After that, place the base part. Then secure the assembly by using 4 M4 rods. In the next step, insert the cable from wind and rain sensor along with the external temperature probe. Now connect all the sensors cable to the PCB board. Prepare the UV sensor and mount it onto the middle cover. I have designed this solar panel specifically for this project. First, we have to solder the terminal wires to the solar panel. Be sure you are connecting to the right polarity. Here I have used 22 AWG wires. Connect the solar panel terminal wires to the PCB board. Install the UV sensor cap onto the top cover. Mount the antenna to the top ring and connect the antenna wire to the LoRa module. Before mounting the PCB, turn on the switch and press the enable button. Now we have to box up all the parts. First we have to mount the middle cover, then the top cover. And at last we have to mount the solar panel. I will recommend to mount the solar panel by using epoxy glue. Align the mounting arm to the main body, then secure it by using 2 screws. Now the weather station is finally ready for the installation. I have used 2 3D printed wall mount to install the wind sensor. You can download the STL files from Thingiverse. The link is given in the video description. I have mounted all the sensors and the Stevenson screen on a wooden pole. I have installed the weather station on the rooftop, which is far away from the tall building and trees. Guys, if you like this video, then don't forget to share it. Please subscribe my YouTube channel by hitting the subscribe button, and don't forget to hit the bell icon so that you will get notified whenever I upload a new video. Thank you. Have a nice day.